State mechanical properties of materials. The mechanical properties of materials are elasticity, fatigue, resilience, hardness, and creep. Let us study each of them one by one. First, let's start with elasticity. Let's take an example of a rubber band. When we stretch a rubber band, the shape of the rubber band gets deformed. Now, when we stop stretching, the rubber band regains its original shape and size. This is due to elastic nature of the rubber band. Thus, elasticity is a property of a material by virtue of which a material can regain its original shape and size after the load is removed. Now let's understand fatigue. To understand fatigue, we first need to understand reverse cyclic loading. Let us take a shaft of a motor which is attached with a pulley. Now, as you can see, when the motor runs, the rotating shaft deflects to and fro from its mean position. When this happens, the shaft is said to be under reverse cyclic fatigue loading condition. This generates a minute crack on the surface of shaft. Thus, fatigue is defined as the phenomenon which leads to a fracture under the reverse cyclic loading with large number of cycles. Now let us understand resilience. To understand resilience, let us take an example of a shock absorber. When this shock absorber is subjected to some load, it gets deformed and some energy gets stored in it. Now when we release this load, the absorber comes back to its original shape or position without creating any permanent deformation. Thus, resilience is defined as a property of a material by virtue of which a material stores some energy without creating any permanent deformation. Now let us understand hardness. Let us take an aluminium plate and a cast iron plate. Now when we hammer these two different plates with the same amount of pressure, we see that there is a penetration mark on the aluminium plate. But in the iron plate, there is no penetration mark. This is because the cast iron plate is harder than the aluminium plate. Thus, hardness is defined as the property of a material by virtue of which a material is able to resist penetration. And finally, we discuss about creep. To understand creep, let us take an example of high-tension electric wires as shown. Over a span of time, these wires sag because of their constant weight that acts continuously. Thus, creep is defined as the property of a material by virtue of which a material deforms continuously under constant loading. Related terms are